Hello guys, welcome to another session on Azure Developer Community. And today we have with us Sanya Sinha ma'am, who will be taking the session forward on the topic on how to create a malaria detection app using Microsoft Azure. I hope it's going to be an insightful session for you all. And without any further delay, let's hand over the mic to ma'am. So, over to you, ma'am. Please continue.
Okay. Thank you so much, Varun. So just please tell me if my screen is visible.
Yes, ma'am. Your screen is perfectly visible.
Okay, thank you. Good afternoon, everyone. Welcome to this session on identifying the malarial parasite in cell images using Microsoft Azure's custom vision service. And we'll be creating a Power application using Microsoft Power Apps, which will integrate our custom vision model in order to create a malaria detection application. So, I hope you all are as excited for this project as I am. So before we actually begin with it, this session is for Global Azure and brought to you by Azure Developer Community. And I'm Sanya. I'm a Gold Microsoft Learn Student Ambassador, Regional Azure Developer Lead, and a published author. And I'm currently working at the University of Texas at Austin as an undergraduate research intern. So let's just begin with the presentation. So the problem statement is that malaria is a life-threatening disease that takes a toll on over 60 million lives annually and affects nearly 240 million people on an annual basis. So if you can take a look at the demography right over here, you can see that malaria is predominantly localized in third world countries, particularly towards the Africas, towards Latin America, Southeast, Southwestern Asia, and so on. Consequently, this paved the need for automated diagnosis because manual diagnosis can be both time consuming as well as cost ineffective. That's why we are going to learn how to use Microsoft Azure in order to create an application that can use Microsoft Azure's custom vision service to accept image based inputs from the users and detect whether the malarial parasite is actually present in it or not. So what it does is that it accepts these image-based inputs, processes it, and then tells whether the malarial parasite, as you can see in this picture, is present in here or not. So basically, you can either use object detection in it in order to detect the presence of the parasite, or you can ensure image classification also, in which you can classify your images as parasitized or uninfected according to your wishes. Without any further ado, let's just start talking about how is malaria detected. So, from the bloodstream of a patient, you need to create a blood smear on a microscopic slide, and it's usually stained with a purplish-colored stain called gypsa. And once it's observed under a powerful microscope, you can actually detect the presence of the Plasmodium parasite. Now, usually we use medical personnel and technicians who are often, employed in order to detect the presence of the parasite. However, usually manual diagnosis techniques are time consuming, cost ineffective, as well as require manual support. Therefore, we are planning on laying the foundation stones for automated diagnosis wherein you could just feed an image into a machine and the machine would automatically tell you into a software which would automatically tell you whether the malarial parasite or plasmodium is present in a cell image or not. So this is what we are trying to do using Microsoft Azure as a service. So, before you actually start working on Microsoft Azure, it's extremely important for you to be familiar with the Azure Portal, which basically contains all the applications, all the services that are provided to you by the Azure cloud. So this is what your Azure portal looks like. If you don't have an Azure subscription, you can opt for either an Azure for Students version, or you can either opt for the Azure free trial subscription as well. So I have access to a subscription that is provided to me, so I'm just simply going to be using that. So this is what your Azure portal looks like. Simply navigate to custom vision. If you don't have custom vision on your main screens, you can use this particular box to navigate through it. Now, this is what your custom vision screen looks like. These are the various custom vision resources that I had created beforehand. If you haven't worked on custom vision before, this particular arena would appear empty. Now, simply click on create. It will take a little time to load. And once it's loaded, you would see a screen that looks like this. So you can either create a training resource, a prediction resource, or both these resources. since we are actually going to accept training images from the user and we are going to use it to make certain predictions, we are going to be selecting both because we need to create both a training as well as a prediction resource. The subscription that I'm going to be using is Visual Studio Enterprise subscription. If you have a different subscription and you don't know which one of it is it that you are using, you can simply navigate to this search bar and type subscriptions. You would see a key like icon that appears over there. Once you hit on it, you can actually see the name of the subscription as well as your subscription key. Now, once you have access to your subscription, it's time for you to use a resource group. If you have a resource group already created, you can simply click on this drop down menu that appears right over here. So, a resource group can be said to be like a container resource that contains all the applications and contains all the elements that you want within your Azure cloud, which you want within your application. So, if you have not created a resource group beforehand, or if you wish to create a new resource group, simply click on create new and type the name of the resource group, which in my case is going to be Malaria Demo 101, and simply hit OK. Now it's time for you to create an instance. So an instance is basically a training resource and a prediction resource, and an instance is typically located inside a resource group. So now when it asks you to select a region, it is typically understood that you need to select a region that is the closest to you, because naturally it would take lesser time for your Azure cloud to fetch it from its data centers that is definitely closest to you, right? Because naturally if you're working on a system in India and you have your instance located in a system in East US, so the fetching time, the retrieval time would automatically be increased significantly. That's why always choose a region that is the closest to your physical region. Next, you can name your instance whatever you want, which in my case is simply going to be Malaria Demo 10001. Now it's time for you to select the pricing tier for your training resource as well as for the prediction resource. So the pricing tier for my training resource that I'm going to be working on is standard S not. You can either opt for a free version of it as well. Next up, you can choose a prediction resource accordingly. So I'm choosing a standard S not tier for both my training as well as my prediction resources. You can choose whatever you want to. Now, once you're done, hit on review plus create. The review plus create basically ensures that the specifications that you have entered are validated. So it basically checks for final validations. Now, as you can see, the validation has been passed. Once your validation has been passed, simply hit create and it would ensure deployment. So just let me fast forward it a little bit because deployment is actually a slow process. So yeah, this is what it looks like once your deployment is complete. This is the deployment name is Microsoft Cognitive Service Custom Vision 2022. The subscription is Visual Studio Enterprise. The resource group is Malaria Demo 101. This is my correlation ID. The start time, the deployment details could be downloaded from here. Now once you have your download done, you can simply navigate to your resource group and you can see the training resource as well as the prediction resource created in your resource group. So this was how you can use Microsoft Azure in order to create a resource group on Microsoft Azure. This is how we have created a custom vision resource. All the other resources that can be created on the Azure portal are created similarly. So there is no difference in the way you create the various resources. There is a difference in the various specifications. For example, if you're working on static apps or something, it won't really ask you for a training resource or a prediction resource. But mostly category, the criteria for all cognitive services remains the same. Anyways, so this is done. Let us start by creating a custom vision model. So in order to start working with custom vision, it's important to have access to the data that we are going to be working with. So this is a data set that I had retrieved from Kaggle. It contains nearly 27,000 images. So there are 13,000 infected images as well as 30,500 uninfected images as well. So you can categorize them accordingly on your system and you can use them accordingly. Naturally, we are not going to be using all the 13,000 images for training. We are going to be using a very small subset of images only. So this is what it looks like once you log on to customvision.ai/projects. If you have not logged in, please log in using your Azure subscription. Now, once you're done with it, hit on new project and enter the specifications. For example, malaria cell detection, detect malaria in cell images could be appropriate description for it. Now select a resource, which in my case is the malaria demo 1001 from the S not tier. Oh, sorry, just one moment. Yeah, malaria demo 1001, the project type is going to be image classification. You can either opt for object detection as well, but for the sake of simplicity and time, we are simply going with image classification. Now the classification types are asked here whether you want a multi-label type of classification or a multi-class kind of classification. This means that in a particular image, how many labels, how many tags do you want to associate with a given image? So every time I'm looking at a malaria infested image, you know that it's either malaria positive or negative. This means that an image cannot be both malaria positive and negative simultaneously. This means that only one tag is going to be associated with a given image. That's why we are simply going to be opting for single tag per image. This means multi-class. This means there are only two classes that we are going to be using, parasitized and the negative of parasitized. Now it's asking for the domain. So since there is no domain that actually corresponds to the purpose behind my project, I'm simply going to select relate to and then hit on create project. Now, this is what it looks like once you log into Azure Portal, hit add images. So I have parasitized right over here. So these images have been infected with the parasite. So once you hit OK, the images would be uploaded. So there are 60 parasitized images that I've uploaded right over here. Now I want to upload certain negative images as well. This means I want to upload certain malaria negative or certain uninfected images as well. So I'm going to navigate to my dataset once again. I'm going to look for uninfected images, test train uninfected, and select a few images from this set also. So just select them and hit open. Now, there are about 90 images that I have selected. You can select as many images as you want. There is just a certain limit for custom vision. I think it's about 9,000, 90,000 images. So just keep the limit constrained within it. Okay. Now, once you have it selected, it automatically asks whether you want the negative tag to be associated with it or not. So since I don't, since this is definitely a negative to the parasitized tag, we are simply going to be using the negative tag right over here, and we are going to click on upload all 90 files. It'll take a little time for the upload to happen, and finally all your files would be uploaded to custom vision. Now you've already added the images, it's time for you to train your model. You can either opt for the quick training option or the advanced training option. So quick training also takes on an average 15 to 20 minutes, and when we're talking about advanced training, you actually have full authority to control how much you want to expend on the training and how much time do you want to take for the training purpose. So we are simply going to opt for the quick training option and hit train. So it's actually a time consuming process. So I'll just skip this video a little bit and fast forward it. Yeah. This is what it looks like once your training has been completed. So this is the first iteration. It finished training on 5th May. The iteration ID is this. The classification type was multi-class. And let's take a look at our performance metrics. So our performance metrics say that the precision for this model was 96.7%. The recall was 96.7% as well as the average precision was 99.9%. So these are some really good metrics, and it's actually really difficult for you to gain such good metrics when you're working on deep learning based image classification or CNN based image classification. So you can even take a look at the performance metrics for each tag. So for 60 parasitized images, you have 100% precision, 91.7% recall, and an average precision of 100%. For an image count of 90 for the negative images, you have a precision of 94.7%, a recall of 100%, and an average precision of 100%. So these are some really great metrics that you have retrieved from your custom vision model. Now, in order to use your custom vision model, it's really important for you to publish it. But before we actually publish it, we're actually going to ensure that our model is working appropriately or not. So simply browse for local files. We're going to look for something from the test images folder. Just test, is it working well or not? Okay. So it says that there's a 98.6% probability of this given image to be malaria negative, which is true because it's actually malaria negative. So this is how you can see how well your model is performing. Now you can choose another image. Let's just choose an infected image from the test folder. Let's just load any image. And it says that there's a 99.9% probability of this image to be parasitized. So our model is performing quite well. So as I said, in order to use your model and integrate it with Power Apps, it's important for you to publish it in the first place. So simply hit on publish. You can choose any name for the model. I am leaving it to the default iteration one. And you need to select the prediction resource, which in our case was malaria demo 10001, and hit publish. Now, once you have published it, you will get access to the prediction URL that you can use when you are linking it with Power Apps. So, this was all about creating the custom vision model. Now, we are going to proceed towards linking it and integrating it with Power Apps. Now, how are you going to create your Power App? First of all, log on to make.powerapps.com. If you have a Microsoft Dynamics 365 subscription, then you can use it. Click on create and then choose the blank app option from right over here. We're going to create the new Canvas app from here. You can either create it for a mobile phone or for tablets. So we are going to be creating it for mobile phones only in order to keep it portable. But you can see how extremely portable is your Power App. So you can choose any name of your choice. I'm simply choosing malaria detector and hit on create. Now it'll take a little time to load. So this is what it looks like once you actually load Power Apps onto your screen. This is what a blank Power App canvas looks like. So now I am a really big fan of the dark mode. So I'm just simply going to change its color to black maybe. Yeah. So now what we are going to be doing is, you can zoom it accordingly. We are linking our Power App with the custom vision service that we had created beforehand. So simply click on this data option from right over here and then look for the connectors option. Within the connectors option, navigate custom vision and then click on add a connection. Now, once you click on add a connection, it asks you for a prediction key and a site URL. You can get access to your prediction key and site URL by navigating to your custom vision portal yet again. So once you click on the prediction URL part of it, since we are only going to be feeding image based inputs and not URL based inputs into our malaria detection application, simply copy this header 2 part of the code, the header 2 part, which is actually going to be your prediction key. So just copy this particular snippet and paste it in the prediction key option right over here. Now you can use your site URL. So in order to get access to your site URL, simply copy this part of the snippet till azure.com. Now copy it and you can paste it in your site URL right over here. Simply hit connect. Now your Power App has been linked to the custom vision application that you had created, the custom vision model that you had created, and you can actually see the data linked right over here. This is how you can link your Power App with a custom vision application. Now, what we are going to be doing is we are going to be adding a few fluid design properties to our application so that it looks a little usable. So simply click on text label and type malaria detector. So I'm just simply going to format this a little bit, maybe bolden the text a little bit, change its color to something more visible. Let's make it something lighter. So let's opt for a light blue shade. Yeah. So you can format the text accordingly by navigating to the through the properties pane. You can select a font size to be something like 30. You can center align your text. And now once you are done with it, you are simply going to add a new button to it because the button is the main functionality behind your Power App. It is going to scan your image based input and it is going to predict the probability of the image input being malaria positive or malaria negative. So now once you have access to it, simply drag your button towards the bottom of the page because as I said, we are adhering to the principles of fluid design. So just drag your button to the bottom of this page. Now you can change the specifications accordingly, changing the text on the button to scan, changing its color to something a little more different, a little more thematic. So maybe a little lighter shade of blue would look better. So let's just opt for something like this. All right. I think it looks good. So once we are done with this, we are going to now write the code for this button. So this is the most important part of this particular project, wherein you are going to write the code for this button that is going to scan your image-based inputs. So go to Advanced Properties for the button and change On Select. We're going to change the value of On Select from false to this particular value. So now we are going to be using Clear Collect. Now what is Clear Collect? Clear Collect basically allows you to create a new collection resource, and from that collection resource, we want it to perform some activities. So the collection resource that we are going to be creating is called gallery call, and I'm going to now specify the item type which gallery call actually is. So from custom vision, it's actually going to classify image version, and it's actually the second version of custom vision. So we're going to be using custom vision classify image version 2 for this, and now within it we are going to specify some specifications. Now it asks for a project ID. In order to get access to your project ID, go back to your custom vision portal, go back to settings, and then you can check out this project ID from right over here. Now copy this project ID, go back to your power apps, and within double quotes just copy it right over here. Now next it asks for a valid name. So the name that we are going to be using for this is the one that was published right over here, which in our case was iteration 1. So just simply copy that name as well, and within quotes provide the name of it. Now, once you have access to it, it asks you for a file name. Now, the file name is something that you are going to accept from the user. What do I want to accept from my user? I want to accept image based inputs. Now, in order to accept image based inputs, what I'm going to be doing is I am going to hit this insert button right over here. Just one moment. Yeah, this insert button right over here, hit media and then hit add picture. Now once you hit on add picture, it will wait for a little while, it asks you to wait for a little while, and then this particular option appears right over here, which once clicked will allow you to add images to your application. Now once you have selected what type of input you want from your user, go back to your button programming and change it to uploaded image 1. Now, uploaded image is the name of this particular application, this particular option that asks you to input image, this particular box that is asking you to input image. And since it's only asking for one image, it's called uploaded image 1. Now, once you are done with this, simply write dot predictions in order to reveal that you actually want to derive predictions from your button. And once you're done with it, your button programming is over. Now that you're done with your button programming, it's time for you to actually see how well your button is working. But before that, we'll have to do a little more work. We'll have to add a vertical gallery to our application in order to display the results well. So it'll ask you for a data source, which in my case is going to be gallery collect that I'd created beforehand. To change the layout to title and subtitle only, because we already have the image being displayed in this big box right over here. And just simply add this particular vertical gallery, slide it towards the bottom in order to make it slightly more legible. So these are all just fluid design semantics that we are adhering to in order to make our application look more attractive and look and have better UI and UX. So just change this color to something lighter maybe so that it's more visible. Yeah, so you can see whatever would be text displayed right over here. So now we are just simply going to format our application a little bit. This is simply just formatting. Now go back, uh, type on gallery 1 and hit on title 2. Now I want my title to basically display the name of the tag. Before that, I'm going to change its font properties a little bit, changing its color to something like deep blue, changing the font value, changing the font weight to bold. And now I'm going to change the functionality of the title to tag name. This means that the title bar in this particular application would be displaying the name of the tag, whether it's positive, which I think it was parasitized, or negative. So this is what it would be displaying. So just hit on this particular box and type this item dot tag name. Now, once you're done with programming the title button, programming the title, you have to program the subtitle as well. Now, the subtitle is what is actually going to give you the percentage probability of a given of a given image of a given malaria infestation. For example, if you have an image and it will tell you what is the probability of this image being malaria positive, being malaria parasized, or malaria negative. So this is what your subtitle box is going to do. So before that, let us just alter the font properties a little bit, maybe make it a little bold, maybe change its color to blue. And before that, we are going to change the specifications, the function of it, to this item dot probability, and I'm going to multiply it by 100 because I want to display it in percentages, and I'm going to round it to two decimal places. So this is how you use the round function. You round whatever you want to round, multiply. This is just a part of the percentage part, and using a comma separator, you can simply specify the digits you want to round it to, which in my case is going to be two, simply two. So using this item dot probability, I am going to round the probability of a particular tag to two decimal places. And after I've rounded it up, I am going to add a percentage sign towards the end of the display number in order to make it look more attractive and make it look like I'm actually displaying and working with percentages. Now, like I said, I'm just going to bolden this text a little bit, increase its font size a little bit, change the color. So this is how you can do. You can simply go to the properties pane and alter the fluid design properties accordingly. So this is what has been done. You can see that it's appearing more legible now. Now just simply click on the run button that appears on the screen. Now you can just see how well your application works. Click on any random image and hit scan. So you can see that the percentage probability of a particular image in this case is 100%. This means that there is a 100% probability of my image being malaria parasitized, because, and it is true because I had actually received it from this particular place as well. Let's just test for another image. Go to test and infected. Yeah, so this is a negative image. As you can see, there is no malaria infestation over here as well. It says there's a 97.3% probability of this being malaria negative, which is true because there is no infestation, and there's just a 2.7% probability of it being parasitized. So this is how you can create a custom vision model, and you can integrate it with Power Apps in order to create such a resilient application. So this was it for the workshop. If you have any doubts, feel free to put them in the comment section, and I would be more than happy to help you out. So if there are no doubts, then I think we can end this session.
So yeah, I think there are no doubts. You explained each and every concept, very thoroughly. It was really very insightful to learn the concepts of Power Apps and Azure Custom Vision. It was really very nice explanation, and you took the problem statement also relevant to the world. Like malaria is, one of the biggest disease. Many people are losing their lives because of this disease, and if we are able to predict it up to so good efficiency, it was really nice to see how you just explain each and everything so thoroughly and explain each and every concept, like every function in that, with proper accuracy, that why we are writing this, how to upload an image and all that stuff. So thank you very much, ma'am, for coming here and taking out your precious time for the community folks. Thank you everyone for being such a lovely and patient audience. See you in the another podcast with ma'am. Till then, stay safe. Bye bye.